There we go. Now we have a recording. What are we doing today? I will show you really quick. I made this brush rig here, and I'm trying to explain my thought process behind what is going on down here. I'll start that over just to make it a little bit easier to understand. It's not. I think it's really difficult to just write stuff down. So I'm a visual learner, as most artists are, I guess. So I have this brush rig, and when it collides with the surface underneath, it does brush stuff, I guess. So we're trying to rebuild that, and I'm going to explain my thought process behind it. So don't save that. Let me have a file open as reference so I don't forget anything. All right, how do we begin? So first of all, we get a curve. Let's create this little curve here. I would like it to be a vector, and I would like to move these around a little bit. So you're there, and you're just in the center here. Doesn't really matter how long they are. I just or where they're placed. I just like to have it this way. Also, let's put the origin to the selection. Doesn't matter either. Too much. I might need to check which one is the start and which is the end. That might be useful to know. But yeah. So, what did I do? The way that this modifiers, like this geometry node setup, is working is I wanted to see where the bottom point of this line is on the surface, on the ground surface, right? And what I noticed is that if this is rotated a little bit, it's a little bit, doesn't really matter. When you look at this line here, I'll rotate it so it's a little bit more readable. I'll rotate it so that it hits this line here, so it's on the fourth line down, right? What I noticed is that when you look at this, it's instead of going down. Oh god, I'm really bad at explaining this kind of stuff. What I noticed is the offset of where the line is underground is the same as from this point in the direction the line is pointing in X, right? So to find this point, I would need to find this point here, I would need to find the distance of this to the ground. So I need to find this ground point, which is 90 degrees. And then I would need to get this distance here and copy that distance over here, offset in this direction. That's the whole thing that I need to do. How do we do that? Well, that's some vector math that we're going to look at right now. And I'm trying to visualize it a little bit. So this is my controller or my guide or whatever you want to call it. And we are going to work on a plane, which will be the brush in the end. So let's call that brush, and let's go into geometry nodes. We don't need the plane, we just need this brush in, not this brush. we need the control in here. So there's my control, and we're just going to look at it from the front. Okay, so we have just 2 points, a start and an end point. Let's visualize them for a second. We have a start, endpoint selection, endpoint selection, and we're gonna sample an index so we get the position of the start and the endpoint. You can basically see it in here as well. Position. We're gonna look at these right now in relative position. So we are at +4, +0.4 here, -0.4 here. Yeah. So we are going to sample index. We are going to sample the index 0 for the start point. We don't need that right now. We're going to sample the position of this point. Position. And we're going to sample the position of the endpoint as well. Just for convenience, I like to work this way. There's probably better ways to do this, but you know. And I always try to keep stuff tidy. So we are going to call this start, pause, and this one end pause, join, and pause. And the way that we can visualize this is by using a point. So let's get a point for a second just to see what is going on here. We have these 2 points here, the start point and the end point. Now, we want to know where these points are on the ground. How do we do that? Well, we get rid of the x-axis. So we are taking this vector here and we separate x, y, z. And then we combine x, y, z. And we set z itself to 0. So this new point here will be on the ground. As you can see, I can change where it is, but we want it to be on the ground. The same goes for the bottom here. So let's duplicate all that stuff and insert it here. So we have the start, ground, pause, and the end ground pause. All right. Now we have this end pause and the start position. Now we need the direction of the start to the end position, because as you know, we want to see where in which direction we need to offset this point. We need to offset it over here somewhere, right? So we need this direction. The way that we get this direction is by like what you usually do in vector math is you have 2 points, and if you subtract 1 point from the other, you get the direction. We want it to be pointing to the right, so we are going to subtract the right point by the left point. So end by start. Subtract this by this, and what we call this is the ground direction. Right now, there's also associated with this right now is also a length, because we're looking at these 2 points. So what we have right now is this length as well. So to further work with this whole thing, it's probably good to just normalize this so we can scale it to the length of this vector down here. So how do we do that? There's a normalize. You could do that differently as well, but usually it's fine to just use the normalize. If you look at this, you can see that it's from the 0 point, it's offset 1 to the right. So it's on 1 right now. Now, we need to get this vector as well, which is we have the end position, here, and we have the end ground position here. We need to do exactly the same thing that we did before. This time doesn't really matter what we subtract from what, but because we're only gonna use the length. We already have the direction, but now we need the length. So we subtract these two from each other, and now we have a vector which from the 0 point will go down here. Let's visualize that for a second. Oh, or up, I guess, because it's the wrong way around. So I will reverse that to make it easier to understand. Now we have this vector here, which is the same length as this vector here, calculated. Now in Blender there's also a length node in vector math down here, length, which returns just the length of the vector, obviously. So this is, I'll just like to label everything properly. This is end to end ground, end to end ground. Okay. And now we want to offset the ground vector by this length, basically scale it. So let's take the ground direction and scale by the length of this. So we have, let's put that in here to visualize it. We have here would be the ground point. Now the distance from here to here, where this point is displayed, is the distance from here to here. Now we just need to say that we want to offset from this ground point here, which we already have. It's the ground end pos. So we take this ground end pos and we are going to add this vector to it. So from this position of the ground, we're gonna add the vector. So we have this point, we're gonna add the vector, and now we get this point. Let's see if that worked. Perfect. Okay. Let's call this new end pause. Okay, we have the new end position, so if we take a new line, curve line, we know that we want to have the start position, which is still at the start, and we want to have an end position, which is the new thing that we calculated right now. Ta-da! We have this funny thing, which if we take our controller here, we probably need to output this properly. If we take our controller here, we can see that it will offset as you would expect. Once it's underground, it will just offset it the way that we want. But there's one problem. If we go up, it is also offsetting the amount that it's over the ground level, which we don't want. So we need to calculate an if statement of the position, if the position of the end handle here is underneath the ground plane, we need to calculate that, and only then we will choose this new position. Otherwise, we will stay with the old position. So what we need is this Z here, and we need to check if it's underneath, if it's under 0. So we need a less than statement for 0. And for the end position here, actually, because we are doing some other stuff later, it's probably better to change that already. Yeah. Instead of doing it this way, I'll set the position here because we want to iterate. So just need to select end handle endpoint selection. We want to have the end size. So we selected the end handle and we set the position to the new position, but we only want to do that if it's under 0. So we can just put in a switch right here. So if it's less than, this checks if underground is true, we want to have this position, and if it's false, we want to have the original position, which we could technically take from here, which makes everything a little bit more messy. We could probably just say position as well, which takes the current position. So if we check that, let me pin the node graph down here and move the controller. As you can see, now it doesn't stay on the ground anymore, and we can freely move it. And this also works in 3D already, or should work in 3D already. I don't know why it did that. Is it using... Okay, I guess there are edge cases that I didn't know about. Otherwise, I'll just do this and maybe it fixes it because I have it this way in my node graph. Okay, that seems more stable. So it's better to just take the end position from there, I guess. clean this up a little bit. So this is the old position. What did I rename? We have the old position, we have the new position, and we've set that. Now, the brush itself also has a little bit of curve to it. It's not just straight, so we need to set the curve handles as well. I didn't really put too much thought into this part, and there's some calculations that could be done with simulations, but the simple this does not seem correct. Did I make a mistake? Maybe. No. Maybe it just looked like it because it was offset. Okay. We need to set the handle positions. All right. So first of all, we need to convert this to a Bezier curve. What's it called? Set spline type. Right now it should be a NURBS curve or polycurve, I guess. But we want it to be Bezier. And we want to set the handle type not to auto but to aligned, and we want to set the handle position to be something that we choose right now. So first of all, why did I check right here and left here? We want to change the handle positions of the end handle and the start handle, and yeah, that should be the other way around usually. So we want this to be the end handle. Endpoint selection, we want to have end size like that, and this one should be the start size. So here we set the right handle, the one that's pointing to the next one, and here we're setting the left handle, the one that's pointing to the previous one, to a certain position. Which position exactly? I chose to take the end ground position that I calculated here. I will set both to the same position, so this one and this one will be there. So it's basically setting this is where the handles of this curve are set. So there's a handle going over here, and there's a handle from the curve that we can't see from this point also over here. Those two handles, but we don't want this to be true if the curve is up here again, as we had previously. And this time I don't want to have a switch argument, not a boolean. I want it to be a little bit more smooth, a little bit more unrealistic, but a little bit smoother. And the way that I did that is by still taking this Z over here and then remapping it. Map range. I want it to start when it's a little bit over the ground, and I want it to go a little bit under the ground to switch. Just checking that I didn't take totally wrong values. You can play around with this. You can also use the switch. I used that first. I just got a little bit better results, I felt like, from this method of like a smooth map range. We don't need the visualizer anymore. We want to mix a vector. So instead of color, we want to choose a vector here. And once it's 1, we want to have B. So this goes into the factor, the map range. And what do we want to choose here? Well, the easiest thing is probably to just use the average point between the start and the end handle, so here in the middle. How do we calculate that? Pretty easy. We have the start and end position, and we're gonna add them together. So add this and this together, and then we scale it by 0.5. And this is the average. This is the average, which will be our default over here. Okay. Actually, let's visualize this point anyway. So point, not the count, but the position, and let's join this together so we can see what's going on. Have the controller. So right now, as you can see, hey Kurt, I am rigging a brush. I just doing a little tutorial thing that I can post, but I like streaming more than doing tutorials, so I thought I'll do it both at the same time. Sorry if I missed your message before, a little bit slow when I'm concentrated. So we have this average point here, and once you get closer to the ground, it will move more and more to this tangential point here. As you can see. So we have figured out how to calculate one of the bristles. Now we need to combine this to work for a lot of them. You can't see that. Okay, good. So I'll just save the file for a second so nothing crashes and we lose everything. This is brush rig tutorial. And I'll open really quickly the old file so I can show what we are doing. So open recent, the ground collision one. Okay, so we still have this controller, but now we want to have more bristles, so when we go down, it will deform to the ground, like a fake collision thing, maybe a real collision thing as you want to see it, I guess, but yeah. Now we're just trying to do all this setup here in the middle. We are not gonna do the simulation because I already also made a simulation how to paint. If you guys want, I can do that, but not necessarily. So let's go back to the tutorial. Don't save that. Okay, so all this stuff here, we don't need this point. All this stuff here is to calculate the ground position of one curve. So let's just, I can group that. Why is it so ugly? Did I not select everything? Ew. I have no idea why it's messing this up. Can I just create a new group and then group? No. Well, I guess I'm not gonna do it then. Ew. Yeah, okay. We're just not gonna bother about that then. Then it's gonna look a little bit more messy, but that's fine. Now, we need to add a repeat zone, which is called for each element now. So for each element. Right now we only have one curve, but we want to run this over a couple of curves. So we're gonna set it to for each spline, and now we just need to have more than one spline entering. I can keep this as a reference to where I want to spawn everything. The way that I set it up right now is that I instance on points 2 times a circle, curve circle, separate ones with the same amount of vertices. So I need integer over here and over here. One may be set to, yeah, right now the top one needs to be smaller than the bottom one, otherwise it deforms weird. I'm still trying to figure that out. But let's set the top one to 0.05 and the bottom one to 0.1. And right now they're just aligned to the ground plane. We want to rotate them properly. Like so. Align rotation to vector. And which vector do we want it to be aligned to? We want it to be aligned to the curve tangent. There we go. So they are aligned. These are separate ones. I don't want them to be instanced on both ends. I just want this one to be on the start and the other one to be on the end. So that means endpoint selection once again. We want this one to be the start and the bottom one to be the end. So we have the start and we have the end, and the start is smaller and the end is bigger. Perfect. Now we can instance on points again, but this time align, because we want to feed in a line into this for each spline. So we have a line curve which it will be instanced. Let's look at that. Perfect. There's a lot of instances in there. All right. And we don't want them to be straight like this. We want them to fan a little bit out to these endpoints. So we are going to realize instances over here, realize these instances, and we want to figure out how to set the position of each endpoint to this circle here. So this endpoint should go on the circle at a certain index. Okay. Now, how do we get that index? I just saved it here in the start. So I store a named attribute on both of them. And it has the same name, like line ID. Line ID here, line ID there. These are both integers, and we want the index. So now every point on the circle has this line ID saved, so it doesn't matter if I instance more things on the on these curves, it will keep this index. Otherwise, I would double the indices when I have a curve, right? So the curve itself has a start and end point, and the start and the end point has its own index. By doing this, I have one index per curve, and I have one extra index per point per curve. So we set position. Again, for the endpoint, do I need to sample index? Wait a second. Did I do that? Yeah, okay, that makes sense. So we sample sample index. The index that we want to sample is the line ID. So we have a named attribute, which is called line ID. We want to sample that. And what do we want to sample there? A vector, which is the position. And this position will go into the set position node here. And when we look at that, now they start small and they end big. Perfect. Let's test if the simulation stuff here works as well. Probably won't, but we'll see. Yes. Why is it not working? It's not working because we output the wrong attribute here. Now it does work. Okay. And it's flattening. Beautiful. But it's also really even, and we don't like that. How do we fix this? Well, first of all, let's add some more vertices. Let's add like 500 or something, so it's pretty dense. Or maybe it's easier to visualize what we're doing. We have these start curves. They have the same amount of points, but we want to offset them a little bit to add some noise. Yes, to add some noise, and the way that we want to add some noise is we have these circles. They are first created here in the center. So we want to set position and mix two values. A vector. We want to mix the current position and the center. So we have the position and 0, 0. And we want to have a random value which drives the whole thing. So when we look at that, we get this funky shape here. We can change it a little bit to make it more extreme, whatever. And we want to have the same thing, just with a different feed for the end curve as well. For the endpoints as well. The circle over here, and just add a little bit of randomness to it. Let's look at what this is doing. This looks much more like a brush now. All right. So we have the basic shape. Now we just need to trim it a little bit because everything is the same length now, so it still looks too even. It's just a hard cut down here, and we don't like that. Let's make it look a little bit more like an actual brush. So we know that we want to trim this curve. We want to trim it from the endpoints, but with a fall off, so that in the middle it stays a little bit more pointy and then it trims back to the outer edge. Luckily we already have the correct values for this. It's this random value down here. As you remember, we have this brings in values from 0 to 1, where 1 is out here and 0 is in here. So we can just reuse this random value node to drive the trim. But as you can notice, if I turn up this, maybe it's still difficult to read. Basically, it's inverted right now. So it's trimming to 0 in the middle, the stuff that's offset more, and it's trimming nothing on the outside. We want to invert this. How do we invert this? By using a map range. Map range. Or actually, because we have values from 0 to 1, we don't even need to use a map range. We can just use a float curve and reverse it, and like that we can already see that works a little bit better, and we can shape it a little bit more as well by just adjusting this curve so it's a little bit more round. So there's shorter brushes on the outside and longer brushes on the middle, so we have a nice and pointy curve. All right. Now let's take this out of the way again and delete the viewer for a second. Move the controller, and as you can see, it is colliding with the ground as we would expect. Goes down, it fans out a little bit. It's not perfect yet. What we could do is add another. We can play around with this first of all to see if we find something that looks a little bit better. But it's pretty hard to shape it in a good way. We can also trim it with another random value, just a tiny little bit, so maybe 0.95 to 1, maybe 0.9, just to thin it out in the end. And like that, we already have this pretty decent little... Oh, 2000 is quite big. These pretty decent brushes. Okay, this, let's name everything again, so it's easy to understand. We have the controller, control, curve. We have the resolution. We have the resolution here. This is the start curve. Start. Actually, circle. And this is the end circle. Offset to center for both of these. This is the line ID. Here we align to the tangent, align to tangent. This is where we get the deform curves, or original curves, orig curves. Set end position here. Set end position. Here we set the profile, so trim to profile, and here we do the whole collision detection. Perfect. Now that we have that, we can change this into a mesh as well. So take these curves, curve to mesh, curve to mesh, with a profile curve which is round, so circle. We need to set a radius, curve radius, probably with a closed tip as well, just for fun. Line parameter factor, load curve, and math, and multiply this by some crazy amount. Something like that. Looks reasonable. To make it a little bit more nice to look at. So right now, because there's only 2 points, we have the maximum set here of the radius and the minimum here. Let's resample this curve just to have a little bit more variety. Resample it like 50 or something. Doesn't matter too much, just gets smoother. So now we can set this to something that looks nice. I think a curve like this is better. Okay. We have that profile curve set. Do we want to set something else as well? I don't think so. Probably we can reduce the resolution. We don't need that much. I think 8 is good. And there we go. We have a working brush right here. Go down and rotate. If we remove the rotation, you can see that it also does this funny thing here. And seems to work as you would expect. Perfect. Okay. That's the brush done. Now we can also do the thing which takes a lot of computing time in the end. Which I wouldn't recommend. I would need to recalculate all that stuff that's going on here, but let's just try it out anyway. So we have this done. Maybe I'll separate it. And now we want to have a new, this is the ground, a new system on the ground for coloring. So this is paint simulation, and this here is the brush collision. We have the ground. Let's center this. I actually want to have a new grid. For the resolution, we need to increase the word count to be pretty high, and we need this, not the controller, we need this brush in here after the whole simulation stuff. That does work, right? Just making sure. Yes, okay. So we have this brush and we have this ground. What we want to figure out is, where do we paint? We do this by using a geometry proximity. There's probably other ways as well, but I'm gonna do this. So geometry proximity. There we go. So we want to see how close are these brushes from the grid. So this distance there, you can already see that it's doing a pretty good job of recognizing where they are. We probably need to remap this whole thing though. We want to work with positive numbers, and not one being the default and 0 being and work with 0 subtracting stuff. That's pretty annoying. So let's use a map range again, map range. And this map range, we will see what distance we want to calculate. So from 0 to, let's say, 0.1, how does this look like? We want to have the values of 1 to 0. We want to clamp it. Okay, this is way too big. So let's reduce that to something that's more like what we're looking for. This looks kind of realistic. It's not perfect, still pretty big, but yeah, I think I'll go with 0.02 right now. We can blur this a little bit. Actually, we can reduce the size and then blur it to see what that does. Maybe we can multiply this a little bit to give it better. Make it look a little bit nicer, I mean. Okay. Blur it like 10 or something. Maybe decrease this a little bit more. 0.005. Oh, round. I think this should work fine. Yeah. So we have these distance data on the ground grid right now. And now we want to iterate on that. So we need a simulation zone. What do we want to feed into this simulation? We want to feed in this grid. Want to feed in this grid. And we want to sample whatever is going on here for every frame and add on top of it and remove some stuff just to so we have a wet map and we have a dry map that we can compare with each other, or a paint map and a wet map that we can compare with each other. Now, we need to store this data somehow, so we have two store attributes right here. One is for the wet map and one is for the dry, but I think I need to reverse them. No, I think that should be fine. Paint map. So we have the wet map here, the paint map on the other side. All right. Let me think for a second how I did this and check with my notes. Okay, so for the wet map, we want it to dry over time, right? So first of all, what we know is we have this we feed every frame, we feed in this data, which should add on top what's coming previously. So if I feed this in here, right now it would always, it wouldn't remember what was in the previous frame. So we need to feed that in from a previous frame. We save, here we save a wet map, so we already have the named attribute wet map, which we can access in the next frame. So we have a named attribute wet map that we can add to the previous frame. Now, if we look at, actually, let me just set a material. Set material, material 0. Oh, my headphones are dying. 1 second. Okay. Need to change my output for a second. Music stopped anyway. Okay. All right. So I wanted to set the material so we can preview it a little bit better in here. We want to go to the shader editor and unpin, get this material going, and we want to have the attribute which we called wet map. Okay, so now if we play, you can see that we add more and more data to whatever we were doing. Just adding more and more data here. Actually, we don't want to go over one. So what I like to do is to put a clamp in here. So we clamp the values between 0 and 1, just to be safe. Yeah. Let's stop that. Now we need to figure out how we can make it dry. The way that we can make it dry is by constantly reducing whatever is coming from the previous frame here. So by subtracting and clamping here, we are adding whatever is coming in the current frame to something that is less strong from the previous frame. So let's look what's going on here. As you can see, if I move this around, it will slowly disappear, but the value won't be going under 1 because I under 0 because I limited it over here. Okay, that's nice. Right now there's some harsh edges, and I would like to reduce them as much as possible. So the way that we can do that is by also blurring here after this whole thing again. So we take this blur, and we just blur whatever is going on here as well, actually. I think 10 should be fine. So let's see how this looks. Okay, looks a lot more smooth. Pretty nice. Hey, Clara. Yeah, it's a pretty long stream already. Took longer to try to explain what is going on. But you should be fine to get the tutorial later. I'll post it on YouTube, and it's in the VOD as well. Okay, so we have the wet map over here. Actually, maybe I'll go over everything once I'm done, if you want to check that out. We have the wet map here, and now we want to have the paint maps where we keep the data. Yeah, where we keep the data, basically. I don't know why I made it so complicated thinking about it, but what did I do? Have this, have that. Oh yeah, basically okay. I only wanted to paint wherever I'm actually painting, so I could change the color, which is not super necessary, but let's do it this way anyway, even though it's not necessary. Here we want to do some similar stuff, right? We still want to get the data from the previous frame, so we need to have a paint map, named attribute called paint map. We need to access that, and we need to add whatever is coming from the previous frame here in there. Now, to make it a little bit nicer, let's blur whatever is happening here a little bit, and just to make sure that it's not going over 1 and under 0, I'm gonna clamp it and put it in here, like so. Make this look decent, kinda. So we have the distance here. Distance. We have the wet map over here. Wet map. And we have the paint map over here. So now if we take a look at these two, paint map, we can put the wet map into the roughness, but we need to invert it. Right now it's just wrong way around. So that's math node. We have subtract 1 from this. And we have this paint map, which goes into the base color. Which we can also invert, I guess. There we go. And now when we take this controller, it doesn't quite do what I wanted it to do. And why is that? Because, oh yeah, that's why I did that. Right now it's still disappearing, so both of them are disappearing, which is not nice. What I actually want is, I don't want, this is happening because every frame the paint map is blurring, but I wanted to blur, but I wanted to stop blurring as well. According to the wet map, it should only blur where the wet map is still active. As soon as it's dry, it shouldn't be blurring anymore. So we take the wet map and we pump it into the weight. And now I should be able to paint and it sticks, right? Yeah. I paint, and wherever I painted, it sticks. Perfect. Like so. Okay. That's the whole thing. I hope that was enlightening, useful. I'll go over everything that we've done again, just to summarize what was going on. So let's go back to the brush here. What did we do? So we got a control curve. On this control curve, on the beginning and the end, we instanced a circle, which we instanced a circle. There we go, we see it. We instanced a circle, which we deformed a little bit, or a lot. We also have a bigger circle that we deformed a little bit differently. Those two were instanced on the start and the end of this curve and aligned properly. There and there. On the start curve or circle, we instanced a line. These lines here. We then took the positions of these end points here and aligned the ends of these lines to those positions, so it's a little bit it's not a straight line, it's a little bit coney, I guess. We then made it look a little bit nicer by trimming whatever is more on the outside of the curve than on the inside, using the same random value we had from this offset over here. And because it looked still a little bit too smooth, we also trimmed with a random value as well. Okay. Now we did all this, and we need to calculate the whole collision stuff. So for each spline that we feed in here, we do this calculation. We take the start and the end position. We calculate where these are on the ground. So we take the start position and the end position. Why ever that isn't doing what it should be doing. I have no idea why it's offset, to be honest. Oh god. Take the start position, take the end position. Look where they are on the ground. Look at what the direction is on the ground. This is the direction. Search for the distance between the endpoint and to the ground, which is this here for some reason. Maybe I should just take the... I'll do a little switch here. Whoop. Yeah, that's better. So we have the start point, start position here. We have the look where it's on the ground, which is there. We have the end position here. And this is where it is on the ground. This is the direction it has on the ground. This is the endpoint to the ground. Here we have the length of this vector. Here we calculate the new position where it should be on the ground, which is over there, which has the same distance. And we create a curve and set its position to that, which is this curve. Then we convert this to a Bezier curve and set the handles to whatever is going on down here, which is we have this ground position and we set it to that ground position as soon as it's low enough. But we also have a switch here and here to check if it's underground, because that stuff should only happen if it's underground, not if it's above ground. And then we resample the curve and we set a profile to make it into a mesh. And if we do that with all these curves that we feed into here, we get a brush. And then, just to make everything complete, we created a little simulation where we took a ground grid, subdivided it a lot, took the distance between the brush and the ground plane, remapped the values a little bit so it looked better, blurred it so it looked better, and ran a simulation to create a wet map and a paint map, which we then can visualize in the material over here, somewhere over here. And we just needed to invert it because we're working with values from 0 to 1, but the other way around. And now if we press space and take the controller and we move it around, we can paint using our geometry node paintbrush, as you would expect. Ta-da! Perfect. Okay, that's all. Thanks for watching. Have a good one.